This problem is an example of Newton's law of cooling. Now, the problem says here that a dead body was found within a closed room of a house where the temperature was a constant 65 degrees Fahrenheit. Now, this is the temperature of the surrounding 65 degrees Fahrenheit. And this also says here that we assume that the time of death corresponds to T is equal to 0. This means that the core temperature of the dead body at the time T is equal to 0 is 98.6 degrees Fahrenheit. This is the initial temperature of the dead body. TO is equal to 98.6 degrees Fahrenheit. Now, at the time of discovery, the core temperature of the body was also determined to be 85 degrees Fahrenheit. Now, for some time T1, the dead body was found and its temperature is recorded as 85 degrees Fahrenheit. Now, 1 hour later, the dead body was found. The time T is equal to T1 plus 1. And the reading of the temperature of the dead body is 80 degrees Fahrenheit. Now, these are the given, and we are tasked, and our goal is to find the value of T1. This is when the time where the dead body is or was found. Now, we have a differential equation here, and this can be derived to find this function T of T here. Our T of T is Ts plus To minus Ts times e to the kt, where your Ts is the temperature of the surrounding and the To is the initial temperature of the body, Ts the surrounding temperature, and your K is the constant of proportionality, and your T is your time in hours. Now, let's substitute these values, these given here, to our function. Our Ts is 65, our To is 98.6, Ts 65, and 98.6 minus 65 is 33. That's why we have T of T here is equal to 65 plus 33.6 e to the kt. Now, let's substitute these values. T of T1 is equal to 85, since the dead body has a temperature recorded of 85 degrees Fahrenheit when T is equal to T1. Now, let's have 85 here is equal to 65 plus 33.6 e to the kt1. And after 1 hour, the dead body was found. The recording temperature is now 80 degrees Fahrenheit. That's why we have 80 here is equal to 65 plus 33.6 e to the k quantity t to the t1 plus 1. Now, let's derive an equation here to find the unknown variables k and t1. Now, let's use this one first to find our equation 1. 85 minus 65 over 33.6 is equal to e to the k t1. Now, this is our equation 1. And let's use this equation here to find our equation 2. We have our equation 2 here, 80 minus 65 all over 33.6 is equal to e to the k t1 plus 1 is equal to e to the k t1 times e to the k. This is just because of the laws of exponent. Now, this is now our equation 2. Now, let's divide equation 2 by equation 1 to cancel the term with t1 here. Since equation 2 is this, 80 minus 65 over 33.6, and our equation 1 is this, 85 minus 65 over 33.6, we have it here. And this also from our equation 2, this, let's put that here, and our equation 1, this, let's put that in our denominator, and let's cancel this so that we're left with e to the k. And now we have only one variable, k, and now we can find this value by just deriving this from this equation. Now e to the k is equal to, we can also cancel this out. Take note here, 33.6 over 33.6. Now we're left with 80 minus 65 all over 85 minus 65 here is equal to, 80 minus 65 is 15, 85 minus 65 is 20, is equal to 3/4. Now our e to the k is 3/4, and we can solve for our k by taking the natural logarithm of both sides of the equation. Now we have ln e to the k is equal to ln of 3/4, and laws of exponents, laws of logarithm, just bring the k down here and we're left with ln e, and since ln of e is just 1, we can ignore this, is equal to ln of 3/4. Now our k now is ln of 3/4, and let's substitute that to our original function t of t here. Now we already have our k value, and if we're given some temperature at time t1, then we can solve for t1. Since we're given the value of 85 degrees Fahrenheit at time t1 when the dead body was found, we can solve for t1. Now 85 minus 65 all over 33.6 is now e to the ln of 3/4 times t1. Now taking the ln to both sides, ln of both sides of the equation, ln 3/4 t1 times ln of e, since this is just 1, is equal to ln of 85 minus 65 is 20 over 33.6. We have here the value of rt1 is ln 20 over 33.6 over ln of 3/4, because we just divide this by ln of 3/4, both sides of the equation, so that we can solve for our t1. Now we can check that our answer is correct, 1.8 hours here. This is the answer, and that's all.